Well, good afternoon or good morning, whenever you happen to be watching this video. This is for Unit 2, Week 3, Lesson 1, Equivalent Ratios. And it's part of our 7th grade unit on introducing proportional relationships. And so what I want you to start off with today is you should get your notebook out and start taking notes. As remember, one of these days I'll be asking you, and one of your assignments will be to upload a picture of your notes from one day of the week. So please make sure you're doing what you're being asked to do. And on Wednesday of this week, we'll be doing textbooks, and I will hopefully have some composition notebooks there too available for students. So let's get started. So here we have today's lesson, and I just need to get my timer going here. There we go. And so what we're working with today is talking about ratios. And one thing I've highlighted now in my lessons that I'll be featuring is if you see a red arrow, you write this down. So for example, I'm going to go like this screen right here, just to make it a little easier so we can talk about that. But I always want you to write down the lesson name, and lesson number would be helpful, name, date, and period. And then the agenda. We're going to be reviewing definitions, discussing equivalent ratios, and using tables to show equivalent ratios. And this really ties into the next steps when we start talking about proportional relationships. So, and then the focus is let's remember what ratios are and talk about equivalent ratios. Okay, so if you need to, just pause the video wherever you are and go ahead, and that way you can then write down your notes and stop it and start it. Just like a Khan Academy video. That's what's nice about these lesson videos, is that you have the power to stop and go back over it. Okay, so you've written those down, and then now let's move on to the process. Here we're going to be taught. Here are some various different ratio definitions. First of all, ratios. A ratio is you might remember this from 6th grade. We talked about them then. Is a relationship between two quantities, normally expressed as a quotient, which prompts a question. Which operation is this? There are 4 operations in math: addition, subtraction, multiplication, and division. Quotient relates to division, as one quantity divided by another. And here's how to express ratios. This is something that we are going to be working with a lot. But these are the 3 ways you express a ratio. And they're all spoken the same way. 3-to-1, or 3-to-2, 3-to-2, or 3-to-2. You notice this one has a colon on it. This has got the word 2, and this is expressed as a fraction. So those are the 3 ways to write a ratio: using a colon, the word 2, or as a fraction. Now, equivalent ratios. What does equivalent mean? Well, equivalent means equal. So these 2 ratios are equivalent or equal to each other if you can multiply each of the numbers in the first ratio by the same factor to get the numbers in the second ratio. So let's break that down. Multiply and factor indicate multiplication. And so for the example they gave us is 8-to-6 is equivalent to 4-to-3. And those numbers might sound familiar because 8 times 1/2 is 4, of course, and 6 times 1/2 is 3. So that's what we're talking about equivalent ratios. Ratios where the first ratio is multiplied by the same factor to get the numbers in the second ratio, and so on and so forth. But I'll be showing you some examples of that here in a moment. And again, make sure you write those down because they have the red arrows. Okay. So let's talk about some examples of equivalent ratios. So here we have 2 ratios. The definition again of equivalent ratios. 2 ratios where the first ratio multiplied by the numbers in the first ratio are multiplied by the same factor, and then to get the numbers in the second ratio. And now we're going to start talking about ratios and describing them in tables and in double number lines. So first we're going to do the tables. And so again, please write this down. You see the red arrow? So you'll have two columns with 1, 2, 3 rows and one heading row right here. So I'll put a little line right there. So you have cups of water and you have cups of drink mix and cups of water. I'm going to put a line right there just to make it a little easier for me to see it. There we go, right here. Oops, my line. Okay, there we go. So a recipe for punch calls to use 3 cups of drink mix and 9 cups of water. So I'm going to put that in there and go 3 cups of drink mix and 9 cups of water. If we use 1 cup of drink mix and 3 cups, it will make a third as much punch. Both recipes will taste the same. Why? Because we're talking about proportions and ratios. So what do? How do we get from 9 to 3? Well, we multiply it by 1/3. Same here. Multiply by 1/3. So let's take that another step. What if I said, well, I need to make a lot more punch? What if I keeping these ratios the same? How much punch would I have if I needed to say like 6 cups of drink mix? How much water would I need? Well, let's look at that. How do I get from 3 to 6? Well, I multiply by 2. So what happens when I multiply? Since I got to use the same factor, I multiply 9 times 2, and what do I get? I'll get 18 cups of water. These are all examples of equivalent fractions, equivalent ratios. Now, let's go ahead and use the double number line. I have in a double number line, please write this down. It has a red arrow next to it. So write 2 number lines, one on top of each other. And the drink mix one is going to be cups, not tablespoons. There we go. Okay, thank you. So what do we do? Well, the first thing I'm going to do with a double number line is I'm always going to start my number lines at 0. Because if I didn't have any drink mix, would I need any water? No. And then I'm going to write in there these ratios that I have. I'm going to start right here with this one right here because it's 1. And then I got 3. So that is 3, and that is 9. And I have 6, and I got 18. So 1, 2, 3, 4, 5, 6, and 18. Okay. So can I enter and put some of those other missing numbers in the number line? Well, I'm going to go 2, 4, and 5. So I'm counting by ones here. And then what I have is I'll go down here and go, well, if it's a 1 to 3 ratio here, that means I multiply by 3. So if I multiply by 3 here, 2 here, how many is that going to be? Well, I got 3. So that would be 6. 2 times 3 is 6. And 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. 6 times 3 is 18. And I could keep going. Say I wanted 10. Let's say I go all the way out here to 10 cups of mix. Well, that'd be what? Would it be 30 cups of water? Yes, it would be. Because again, what am I doing? I'm multiplying times 3. So here's examples of using a double number line as well as a table. Tables up here, double number lines here. You should have that in your notes. Again, you can stop me anytime, rewind it, but just make sure you get these in your notes in your book about a table to express equivalent ratios and a double number line that expresses equivalent ratios. So here we have using a table to show equivalent ratios. So here again, I'm going to take my screen down, start right here. Notice the red arrow, so you'll need a table that is 2 columns by 1, 2, 3, 4, 5 rows with the headings up top. So here we're going to start with the first ratio, a 1 to 3. We know that because that's the example we've been using. So then if I go down, I got 2 and 6 multiplied by 2. Go down one more. And I'm multiplying by 3. This is my first ratio here. And the second ratio, third ratio, but I happen to be multiplying by 3. That's not decimal there. I'm going to kind of get that a little. This is the multiplication sign, and I got to be careful how I write that. It's not a decimal because instead of using, 2 times 3 equals 6, in 7th grade, we switched to this kind of notation. 2 times 3 equals 6. Same thing, but x, we use more of a variable in 7th grade, so that's why we want to make sure we don't use it for that. Okay, so let's move on down on a good one. 4 and 12. So now, what would be the factor, the same factor that I multiplied these two by to get to from 1 to 3 to a 4 to 12 ratio? Well, if you said multiply by 4, you would be correct. So put a number in here. Let me give you a number. How about number 7? What would this number be? Well, 7 times 3 would be 21. So 7 to 21 is this equivalent ratio to 1 to 3 and all those ratios above it. Okay. Let's move on now to... Now here's an example that's a little bit more complicated. So we're going to take this away. Here are 3 recipes. And 2 of these mixtures taste the same and 1 tastes different. Why? Well, recipe 1 has mixed 4 cups of orange juice with 6 cups of pineapple juice. Recipe 2 has 6 cups of orange juice with 9 cups of pineapple juice. Recipe 3 has 9 cups of orange juice with 12 cups of pineapple juice. 2 will taste the same, 1 will taste different. Explain or show your reasoning. Well, first of all, I draw a table out, 1, 2, and 3. Then I put in what I know, orange juice and pineapple juice. And then I put in a little squiggle there to kind of separate them. Then I put in my ratios. Here's 4 to 6, 6 to 9, and 9 to 12. So those are my first ratios or my original ratios. So now then I'm going to look at this and go, well, what if I go, okay, so I go down one more and make some equivalent ratios. Well, notice that I have this one here, recipe number 1 has a 2 to 3 ratio. Recipe number 2 has a 2 to 3 ratio, but recipe number 3 is a 3 to 4 ratio. What do we see? What do we know? What do you wonder? Well, these are the same. So recipe number 1 and 2 must be the same. And recipe number 4 will taste different. And you would take that a little step further, and you can go all the way down and see that they, again, are the same here. And this one is different. It's about those equivalent ratios. These obviously are equivalent ratios because to get to here, I divided by 2. To get to here, I divided by each of those by 3. And I divided each of these by 2 to get to that next row. So ratios can be equivalent, and tables are a great way of looking at it. Double number lines work also, but I'm a big fan of tables.